Hello everyone and welcome to my YouTube channel. My name is Subhashish Mishra and today's topic of discussion is on measures of dispersion. Now before we start, if you are new to my channel, please subscribe, like and share so that you will be able to notify whenever any new video gets uploaded, as I am constantly uploading videos for the journey of being a machine learning specialist. Now let's get started. So what is dispersion? Dispersion is the spread of distribution of the data based on the average or mean specified. So it is basically the measure to find out the distance between each data point in the numerical data set. There are two major categories of dispersion. One is absolute measure of dispersion and another one is relative measure of dispersion. Now let's discuss one by one. In absolute measures of dispersion, it is being used to measure the dispersion in absolute terms, that is the units of the original data. Whereas the relative measure of dispersion is expressed in relative terms. For example, if we are saying that we have a small farm and its profit for the month is 400 rupees, then it is called as absolute measure of dispersion. But whenever we say that the profit for the month is 10% more than the profit of the last month, then it is called relative measure. Okay. Now there are five major different ways of calculating absolute measure of dispersion and four major types of relative measure of dispersion. So let's discuss one by one. Let's say we have a data set which is having the range, which is having the 5, 10, 15, 20, 20, 40 and 60 as the units. So the first measure of dispersion is range. So how we can be able to find out the range? The range is, as the name suggests, the difference between max and mean. So here the max is 60 and the mean is 5. So the range is 55. Let's say we have another one data set which has the data points as 1, 2, 3, 4, 5 and 9. So what is the range for this second set of data? So it's 9 minus 1, which is 8. As simple as that. The second measure of dispersion, absolute dispersion, is variance. So what is variance? Variance is being calculated as the distance of each and every data point, square distance of each and every data point from the mean. So how we can be able to calculate? For that, first of all, we have to calculate the mean. For the first data set, what is the mean? I'm cutting down the chase of calculating each and everything else, and the mean is 25. Okay. For the second data set, the mean is 4. Okay. Now, for the variance, how we can be able to find it out? As the formula says, that it is the square distance of each and every unit from the mean. So 5 minus 25 square. Just imagine that this 2 is square. Okay, is the representation of square. Plus then 15 minus 25 square plus then 20 minus 25 square plus then 40 minus 25 square plus 60 minus 25 and then we find out the average of it. Average means the number of data points we divided with the number of data points. So which comes out to be like 5 minus 25 is minus 20 into square of minus 20 is 400 plus 10 minus 25 is 15, square of 15 is 225 plus 15 minus 25 is 10, square of 10 is 100 plus 20 minus 25 is minus 5, square of minus 5 is 25 plus 40 minus 25 is 15. Again, the square of 15 is 2 to 5. Plus 60 minus 25 is 35. The square of 35 is 1 to 2, 5. So we sum up all of them and divide with the number of data points we have, which comes out to be 2200 divided by 6, which is 366.67. Okay. Similarly, if we will say that the variance for the second data set, again I'm skipping the calculation part, and the variance of second data set is 0.67. Okay, so by the looks of it, we can be able to say that the first data set is more dispersed than the second data set. But here there is one problem. The measure of dispersion in case of variance is always coming in squared. If the data set that we have has the measure in meter or centimeter, then in case of variance we will be finding out like meter square or centimeter square, which is not the right way of finding out the measure of dispersion. So because of that, what we do, we go ahead and find out the standard deviation. Okay, so for the standard deviation for the first data set is, what is the standard deviation? It's simply the square root of variance. So the square root of what? 366.7, 366.67, which comes out to be 61.11. Okay, so the same, the standard deviation, the deviation for second data set is again the square root of 6.67, which comes out to be 1.11. Okay, so now by looking at the two standard deviation score, we can be able to easily say that the first data set is more dispersed than the second data set, as the standard deviation of the first data set comes out as 61.11. So it is 61 times more dispersed than the second data set. Okay, so this is the third absolute measure of dispersion. Let's discuss about another one measure of dispersion, which is the quartile deviation. Quartile deviation. So it's very simple. Quartile deviation is being the deviation calculated in terms of median. So here we will be calculating median. But in the measure of central tendency, what we have done, we have calculated only single median. Here we will be calculating three medians, because of which we can be able to divide the entire set of data into four different parts, so that we can be able to find out the measure of dispersion of each and every part of the data. Okay, so how we can be able to do that? Let's take the example of the first data set itself that we have taken. And what is the median of it? Median is the difference, the average between 15 and 20. Average of 15, 20, which comes out to be 17.5. So if we have even number of data sets and we are calculating the quartile, that is Q1 and Q3, because median is Q2 or the medium. Okay, so we will be calculating Q1 and Q3 for the same. So for the calculation of Q1 and Q3, we will be calculating anything else up before the median value. So the median value is 17.5. So anything else before the median will come under the calculation of quartile 1. So what are the data points? 5, 10 and 15. So what is the Q1 then? Between 5, 10 and 15, what is the median? 10. For Q3, similarly, anything else after the median will be considered to be calculated in the quartile 3. So what are the data points after 17.5? 20, 40 and 60. So Q3 is 40. Okay, this is when we have even number of data sets. Let's say we have odd number of data points 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say this is what the data set is. So here the median of Q2 is 5. As simple as that. Okay, now anything, the Q1 will be anything else before the median. So 5 is the median. So whatever before 5 will be considered to be calculated for the Q1. So median of 1, 2, 3, 4 is what? Average of 2 and 3, which is called as 2.5. Okay, similarly for Q3, it's after the data points after 5. So 6, 7, 8, 9. So similarly, average of among 6, 7, 8, 9 to find out the median. What is the median? Average of 7 and 8. So average in 7 and 8 comes out to be 7.5. So this is Q3. If we have to find out the interquartile range, which is very simple, Q3 minus Q1. So here the Q3 minus Q1 is 5, which is the IQR is 5. Here the IQR will be 30. Okay, now let's discuss the last measure of dispersion, with absolute dispersion, which is called as mean deviation. So by the looks of it, mean deviation is to calculate each and every data point, how far all the data points that we have from the mean. Okay, so let's take the example of this data set itself. Okay, so what is the mean of it? 25. Okay, so here we find out the mean absolute deviation. Okay, how absolute is the deviation from the mean? Okay, so how we can be able to calculate? So we find out the difference of each and every data point from the mean, the absolute difference, and then we average them out. So how we can be able to calculate this thing? And of this way it will be more easy for us to calculate, because we don't have to use the pipe again. Alright. Okay, so here 5 divided by 25, 10 minus 25, sorry, 5 minus 25, 10 minus 25, 15 minus 25, 20 minus 25, 40 minus 25, 60 minus 25. So once this is being done, so what is it? So it's like 5 minus 25 is 20 plus 5 minus 25 absolute is 20. 10 minus 25, it's minus 15. The absolute of minus 15 is 15. Okay, again 20 minus 25 minus 5, the absolute of minus 5 is 5. 40 minus 25 is 15. Absolute of 15 is always 15. 60 minus 25 is 35. Then we sum all of them and we divide them with. Okay, so what is it? 105 divided by 6. So that comes out to be 17.5. So that concludes the absolute measure of dispersion. There are relative measure of dispersion, which are basically calculating the coefficients, which are very rarely used, and they're very simple also. There are formula available for them. I will post them in the description. I hope you guys can be able to carry it out. If any kind of doubt you guys have, then you can post it in the comment section and I'll happy to help you out. Alright, so that's all about the measure of dispersion. In the next section, how we going to discuss about hypothesis testing, and also the null hypothesis and alternative hypothesis. Until then, stay tuned. Thank you.